Okay, so here is the 3D printing of the wing bone. This is the part that will hold multiple sections, two sections of the wing together along the perpendicular axis to your body. Whatever that means, it's hard to visualize here, I know, but yeah, I just wanted to show this 3D printing. You can see there's a little bit of an issue with the bottom hole. You can see there's a little bit of a droop in the filament on that hole because it's a perfect circle. And you can see here there's another issue on the right side. You see it's starting to droop, the filament's starting to clog up a little bit, and yeah, I needed to figure out how to fix that. At first I was thinking it was wet filament. Ben from the future here, he thinks it's the seam, but it's not. Just letting you know. Hole on the top as well, same issue as the bottom hole. Yep, and there's our part completed. So I just pop that off the build plate and take a closer look at it here. Yeah, and there's a close-up, nice close-up. You can see those lines, the drooping, over extrusion looks like, or I don't know, sloppy extrusion, whatever. So yeah, it turned out it wasn't wet filament. I looked at the slicer, found the seam was right here. It was set to aligned, and so I just changed the seam to back, and that looked like a better seam line. Looked like it was more uniform anyways, like it would be less likely to have the same issue. Then I went into Blender here and took the holes and just took the edges of them and expanded them along the y-axis, or the vertical axis, as they're going to be printed, hoping that that would fix the drooping issue. I then exported it as STL, clicked and dragged it into Orca, scaled it up to 2,400%. That's just the arbitrary scaling that I'm using for my project right now, and rotated it so that the camera can see it right there. Then we need to slice that. You see I've got 4 skirts and a little bit of a brim to ensure successful printing. The new seam, you can also see the holes with the updated top and bottom ridges expanded along the vertical axis. And yeah, here we go, printing again. Yeah, this is also the stuff I use. It's called Layer Near Bed Weld. Really good stuff. I use this with literally every single 3D print ever. Definitely not figuratively, literally. Yep. Okay, here we go. Here's the second attempt. And looking good so far. Okay, right up until, oh no, you can see that, yeah, the lip is rising up. Looks like, looks even worse than the first attempt. Looks like the edges of the lips are rising up, and it's causing some resistance, causing an under extrusion of some sort. And yeah, that's not good. That's not going to work. I think I should probably just make them ovals. I think ovals would probably work better, much more gradual. And then it recovers, and it looks like we're doing good right up until, yeah, oof, yep. Looks like the overhang was just a little bit too steep. So it's actually stretching out beyond the outer perimeter where there is no existing filament. And then what's happening is it's drooping down below the previous layer that was already printed. So yeah, that is not a pretty sight. And yeah, you can see here again, here's another close-up of what's happening with that nozzle. Running into the lip, which is rising up, I suppose, because it's cooling too quickly. And yeah, so I think we're just going to make them oval shapes, and that should be good enough. And here is what the print looks like when it's done. As you can see, the lines are still messed up, and the holes are still messed up. And as you can see here, the seam was clearly not the issue. So let's try again. The first issue I wanted to fix was the holes. As you can see here, I manually try to recircle them because I'm a complete noob at Blender, and I fail. And we then see that failure manifest in the 3D printed part where two of the holes are actually slightly different. I then turn the holes into ovals, thinking this will work better, most likely, and I wanted to also expand the outer shell, outer curvature of the piece to reduce the overhangs and hopefully solve the problem of the filament drooping over the edge as well. And while importing it into Orca, I accidentally select a much older file made of a completely different material, TPU, not PETG, which I'm using right now. And the older file, as it turns out, is a .3mf from last month, which then changes all of my Orca Slicer settings to whatever they used to be a month ago, which, as it turns out, is much different than what I'm trying to do right now. Surely nothing is going to go wrong this time, right, guys? So here is the new part being printed with settings from a month ago, in addition to a build plate that was not leveled after aggressively bending the plate like a redacted. So in addition to the current bed leveling issue, and the settings from a month ago, you can see here the print gradually gets worse and worse until finally it pushes down so hard on one side that it lifts up the opposite side of the print and it fails miserably. And here's the rest of the failed print. Now time to reapply a fresh coat of glue to the bed and try again with the new model with the correct settings. I'm using a low density triangular infill to just get a few ridges around the outer perimeter to increase stability. But yeah, anyways, the oval shapes appear to still have some drooping here. This is due to the fact that the two holes were different. It would appear that I brought the top edge of one of the holes too far in, so it is not actually a perfect oval, which is causing the extrusion to be delayed and to droop briefly and to be printed as a overhang, which, yeah, that's my fault. It's a quick fix. We can deal with that, no problem. And so far so good. Keep on going, everything looking great, parts looking fantastic so far. Layer adhesion is excellent. The angle, the slight offset angle as well, I noticed is really good for layer adhesion between outer perimeters, which is really nice. Yeah, and here it is. Here's the upper oval looking fantastic. Basically perfect. I mean, that's good enough, right? I mean, that's very good in my opinion. That's perfectly good. That will work. This is a functioning engineering prototype. You know, it's not meant to be a work of art. But yeah, it is always nice to see, you know, when your print settings are dialed in very well. This is Overture white PETG. I believe I'm printing this at about 245 Celsius nozzle temp with 72 Celsius bed. And yeah, here's the rest of the print, and then we'll go ahead and pop it off and take a look at it. Layer adhesion is looking really good. Basically like glass. I really love this white Overture PETG. I'm not sure what they add into it, whether it's titanium dioxide or some kind of a chalk powder or something, but it prints really, really well. When this stuff liquefies, the layer adhesion is basically flawless. And also, an added benefit of the white filament is, of course, the temperature resistance. So it reflects the sunlight for outside conditions, which would lower the temperature and reduce risk of warping over time. So yeah, it looks pretty good. The seam line does stand out a little bit. Also on the top and bottom surfaces, I see there's a couple of gaps because of the old settings that I imported. The gap fill was turned off, so I'll have to turn that back on and fix the oval, and then we'll print it again. Here we go. Alright, you know what they say, fourth time's a charm, I think. Yeah, something like that, right? So anyways, here we go. As you can see, there's a little bit of goop that's still attached to the nozzle. I need to probably put some kind of nozzle scraper on the bed, and yeah, I don't know, normally I just go in there with a pair of tweezers and just, pluck it off, but I figured this probably wouldn't cause a problem. Although, as it turns out, pretty soon here, it does end up coming loose. And there it goes. And it's going to get deposited on the, I believe, looks like the inner wall. Yep. It's going to get deposited on the inner wall of the piece towards the top. Luckily, this did not result in a critical failure of the part. It looks like everything still recovered nicely, and it didn't really make that big of a deal. But yeah, future reference, I mean, you really should have some kind of a nozzle scraper or something to take care of the goop before your print starts, or just, double check, look at your nozzle, and if there is goop on it when the print begins, just go ahead and pick it off before the motor starts running. Yeah. Okay, so here is our final product. The oval holes are not quite perfect, but they are usable, and they do work for my purposes. Like I said, oh, well, we got a little bit of, all right, that's the little bit of goop in there. Looks like a llama or something, the shape of an animal. Inside of our print here, just gonna get some tweezers and pop that out really quick. Everything else on the print looks good, though. I would say the quality is very good, except for, there's still a little bit of droop on the oval holes, whatever, big deal. As long as it's, structural, as long as the structural integrity is good, that's all I care about. Yeah, because it just needs to maintain its form while in use, so that I don't fall out of the sky and die. So yes, I would say it is good enough. Very good. I'm satisfied with it. I might come back to this and fix it, clean it up a little bit more later as we continue developing the part. But this is it for now. Okay, thank you for watching. Don't forget to like and subscribe. And if you like this video, please let me know in the comments what you would like to see next. Although I probably already have something planned. Blah, 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 blah. Cutting this. Thanks for watching. Okay. Take care. Bye-bye.